Okay. So we are looking at page 20, types of waves. Of course, we're going to cut out our flip-flap. We're going to talk about the two different kinds of mechanical waves. There are transverse waves and longitudinal waves. The main difference is that one runs perpendicular and one runs parallel. This is where it becomes vitally important that you understand the difference between perpendicular and parallel. Because both of these waves, although they look extremely different, are doing the same thing. They are both oscillating at a consistent speed with a consistent oscillation rate. Okay? Go ahead, cut it out. We're going to glue it down to page 20, types of mechanical waves. And then from here on out, we're actually going to talk about all waves as being either longitudinal or transverse. We're even going to consider those electromagnetic, those light waves, as transverse waves, because that's what they are depicted as in pretty much everything. Reagan, do you have a question?
Well, yeah, but what was 19's title called?
Intro to Waves.
Okay.
Correct, Nathan. Correct. A T is perpendicular, whereas like LL is parallel, which is why parallel tells us what we need to know. Because there are parallel lines in the word parallel. All right. Okay, so some of you have already gotten started on this. Some of you might have already even tried to take these notes yourself. So we're going to make sure that you have these aligned with, what you thought the answers were. We're going to start with actually longitudinal waves, because these look the weirdest. Now, tomorrow we're going to get into parts of a wave, but what I want you to recognize is that this and this are referred to as a crest. This is the top, quote unquote, the top of the wave. So when you look at the transverse image, this and this are also the crests. Okay? Remember, these waves are it's the same wavelength. It's the same rate of oscillation. They're both going the same speed. The only reason that they look different is because this one's perpendicular and this one's parallel to the movement. So, if these are the crests, then these lower parts here are called a trough, like a feed trough. They dip down to hold water or feed. On a longitudinal wave, Zeppelin, I'll get to you in just a second. On a longitudinal wave, this is where the lines are the furthest apart. This is that trough. Zeppelin, do you have a question?
Yeah. What are the waves doing? What do they do exactly?
As in, what is their purpose in the overall nature of existence?
Yes.
They transfer energy. It is how energy moves from place to place.
That's what I thought.
Okay.
But my brain kept wondering. Goodbye.
Yes. Nathan, the crest is the top and the closest together. The bottom is the trough or the furthest apart. Skylar, do you have a question?
Okay, so are we writing this stuff down?
Yes.
Okay.
You plan on remaining unconfused. Dylan, you have a question?
Yes. Are we going to get into World War One?
Don't know.
Okay.
Social studies pacing is definitely slowing down because of the nature of our existence right now.
Okay.
Okay? Excellent question, though. All right. So, back to our discussion of longitudinal waves. So, what defines a longitudinal wave is the fact that these particles, represented here by these lines, the particles of the medium, right? Let's call it the air. This is the nitrogen particles, the hydrogen particles, oxygen, carbon, whatever you want to call it. These are those particles vibrating. Now, what they're doing is they're moving back and forth. They're kind of crashing into each other. Have you ever seen the Edison's cradle? It's the Edison's cradle is the contraption that looks like a swing set, and you have the one ball, and you drop it, and it smacks in, and then the other one flies up, and they go back and forth like this.
I have one of those.
Yeah, that is the same idea of a longitudinal wave.
Pendulum.
That force, that energy is being transferred parallel to the movement. Does that make sense? General head nods. Great.
Were you talking about the longitude one that like goes like this, like parallel? Or are you talking about the transverse one?
Talking about longitudinal, because it runs parallel. Yep.
Okay.
Mr. It.
Would that count as a drum, Clayton? So drum is a sound, right? It's creating a sound. It's that concussive force. The wave, the particles are moving parallel to the movement of that sound. So, yes, if that answers your question the way you wanted it. Unsure.
Charlie has a question.
Who? What?
Charlie.
I have a question.
What's
Did
up?
you lose me for a second?
Maybe?
Because I went out.
I
went outside to
periodically
see.
mute people.
I had to exit out because my Wi-Fi wasn't exactly working for a second. So then I had to, because I went outside because it was a little loud because of my sisters, and then I came back in and turned my Wi-Fi on, and I had to turn it back on, and then
That's
so
all
I
right.
got back in the meeting. So
Cool.
if you lost me, that's what happened.
Alrighty. So a longitudinal wave is defined as the particles. Let me focus the camera. Maybe is it that button? Yeah. The particles of the medium moving parallel. Okay? Parallel. To the movement of the wave.
Miss Starrett,
Yes, sir?
so when it's moving parallel, when the particles are moving parallel,
Yes, sir?
do they move with force, like great force, or are they just easing through?
That depends entirely on the amount of energy being transferred.
So if it's like in, let's say, like a battery, and if you have all your amps up on it, and if you're like trying to jump like your car or something, it's going to be moving with force.
Yeah, I mean, you're going to be transferring more energy.
And and even with your jumper cables, will it be moving with twice of it because you got the black and the red?
Well, that you're looking when you have the black and red, you're looking at a grounding wire. That's for your safety, and then you're looking at the red wire, which is actually transferring that energy. So really, it's only the red wire that is transferring that energy there. So if a wave moves, from left to right, then we have those particles. Then the particle, whoops, not moving, move from left to right. Obviously, if the wave is moving up and down, then those particles are moving up and down. Charlie, did you have a question?
Yes, I do. So would this be right? This is what I put it. I said particles of a medium moves in the same direction of the wave.
Yes. So looking for that parallel. You're going to hear me use the word parallel a lot.
Okay. Have we done transverse wave? Okay.
No, we started with parallel we started with longitudinal because it's the one that looks the funniest.
Okay, yeah.
Derek, go back to your screen. I can't see it.
Huh?
Go back to your screen. I can't see it.
This is my screen.
Oh, there we go.
Yeah, she's on her screen.
The only reason why it moves from the screen is because somebody else is talking, so it moves to their screen.
You're making a noise.
Mute yourselves.
Like I said, I'll go through periodically, make sure everybody's muted.
Mrs. Sterrett?
Yeah?
So, Ben told me that he didn't get the link to Zoom.
Okay. I will send him another link. I will resend it to him.
Kylie, if you're trying to talk, you're on mute.
Miss Jarrett.
Hold on. I'm sending Ben an email.
Okay.
Kind of look like Kylie, you were trying to talk. No? Okay. So unless you know, if you're trying to talk, you're still on mute.
All right, Mr. Jones. How can I help you?
Okay, there, I was unmuting myself. So thank you for doing this. So are we gonna move on to the next one?
We are. We're moving on right now. So
Okay.
transverse waves are the definition and example. It's pretty much the same. So the only thing is we're going to change one word. In a transverse wave, the particles of the medium are moving perpendicular to the movement of the wave.
Mr. That's kind of similar to what I had down. I said particles of a medium moves in a perpendicular direction of the wave.
Yes.
Okay. Just making sure that's right.
Yep. Okay. So this means if the wave moves from left to right, then the particles can move two different directions. They can move two different directions. The particles can either move up and down or side to side, because we live in 3 planes of existence, right? 3-dimensional world. If you have a wave that is moving along, let's say, the length of a box, then the particles can either travel along the depth of that box or the height of that box. Pulling in some of that mathematics, remember, it's a 3-dimensional world. We've got 6 cardinal directions: up and down, left and right, front to back.
Miss Sarah, I do have a question.
Yes, ma'am.
Is Miss Hayden gonna wait, does Miss Hayden already have today's lesson and homework, or well, she usually doesn't yesterday.
They
Okay.
have the entire week up.
Oh, okay. That's right. Yeah, I remember that now.
Yep.
That, yeah. Okay.
Mhm.
Thanks.